Hello, good morning. It's the last marking period, and unfortunately, this is the way it's going to be from now until the end of the year. It's not what I wanted. I'm sure that's probably not what you wanted either. This is not nearly as much fun. Today, we're going to recap solubility, and we're going to learn about the rate of solubility and what it means to be saturated and supersaturated. We're not going to have any homework tonight, though. Okay. Remember, solubility is the ability of something to dissolve in something else. So essentially, you have three types of solutions: solids in liquids, liquids in liquids, and then usually metals with metals. But you also have gases too. Gases can be a solution as well. Remember also that solutes are dissolved in solvents. So the most common solvent is water, but you can also have a situation where you have air particles, like what I'm breathing right now. Air particles have a smaller component and a larger component. The biggest component is nitrogen. That means nitrogen is the solvent, and the other gases are dissolved in it, like oxygen and carbon dioxide and water. Okay? So that's solubility. That's solvent and solute. What determines, these are the types of solutions. And we also worked with table F, using this chart to determine what would be something that would be soluble in water or not. Okay? And the things that affect solubility is something we also learned. Remember that like dissolves like, in that if there are polar molecules like water, polar molecules will dissolve things that are charged or things that are partially charged, like polar molecules. Temperature also affects it. In general, the warmer the temperature, the more it's going to dissolve. But also, the opposite of that is true with gases. In gases, when you increase the temperature, and we talked about soda, if you increase the temperature, you're going to have fewer gases be able to be dissolved in there. That's why when you warm up or leave out a soda out on the counter, it's going to get flat. That means that the extra temperature is going to push the carbonation out of there, the carbon dioxide. And lastly, pressure. For solids and liquids, the pressure doesn't really have any effect. But if you've got in a gas, if it's under pressure, you keep it capped to keep the carbonation in there. Okay, so today we're going to be learning about factors affecting the rate at which something dissolves, how fast the substance dissolves. So now, not how much, but how fast. Well, the size of the particles have something to do with it. The larger the particle size, the relatively less surface area. This results in more of the solute being hidden inside the solute. So the general rule is the bigger the size, the slower the rate of solution. Now, I've got a little setup here. I've got a Tums in here, and I've got a Tums in here, and this one I've crushed. Now you can see that this is powder, essentially. I'm going to add the same amount of water to each one of these. Each one's going to get 50. Probably tell already, it's not going to take long for the one in this hand to dissolve. This one's breaking down as well, but Now, at this point, you can't see it very well. Tums has got a lot of stuff in there that is not soluble. That means it's not going to make a solution. It's going to make something called a colloid. But you can see that they're really, except for the top, there's some on the bottom actually. The smaller the particle size, the faster it will dissolve. Now I could have used sugar, a sugar cube, or a pile of salt versus a little tiny salt block, but you get the idea. Okay? All right, what's next? So the bigger the size, the slower the rate. You make it really small, the water can get to it. The solvent can get to it. Another thing that you can do to increase the speed at which it dissolves is stirring it. And you know that already. Stirring can increase the rate. Another part is amount of solute that's already dissolved. If I continued to add to each of these, at some point it's going to start to slow down because there won't be enough water particles to completely surround and dissolve the solid particles. So if I increase the amount of solute dissolved, it slows the rate. So an increased amount, the slower the rate. The more salt that I put into water, the longer it's going to take for the salt to dissolve. And lastly, temperature. For temperature in solids, for liquids and solids, an increase in temperature causes an increase in the rate. You know that if you wanted to dissolve something quickly, you warm it up. Like if you were making hot chocolate, if you made it with cold milk, it would take quite a long time to get it to dissolve versus if you had hot milk. For gases, an increase in temperature causes a decrease in rate. And that's for the same reason. Okay? So, make sure you can access that information. The last little chunk for today is these things called, these solutions which are described as saturated, unsaturated, or supersaturated. And we do have to know the difference between them. Saturated solution has dissolved in it all the solute it can hold at a given temperature and pressure. And I've got a chart that I can look up, and I will give it to you if it's not in your packet, but I think it is. It's a chart to show you at what temperature can water hold what amount. So the rate of dissolving, when this happens, the rate of dissolving equals the rate of crystallization. And I'll show you a little demo. I'll show you a little demo tomorrow. If it's unsaturated, it contains less solute that can hold under. Now, how can I figure that out? Well, I could start with some water and add salt and keep adding to the point where I end up with salt on the bottom. Once it's reached the bottom, that means it can't dissolve anymore and it's got crystals. So at that point, where even if I can see it any at all, that means it is saturated. But up until that point, it is unsaturated. So I can figure out my saturation point. Okay? If it's unsaturated, that means the rate of dissolving is greater than the rate of crystallizing. So when I put crystals in there, it will dissolve. And at some point, it will become saturated. So unsaturated solutions will become saturated at the given temperature, whatever the temperature is, as long as you keep putting the solute in there. And lastly, supersaturated. In this case, you have more dissolved solute than is present in a saturated solution. Well, how can you do that? Well, you make a saturated solution, and then you increase the temperature. Then add more solute, then cool it gradually, and be careful. I've got a supersaturated solution, and I've shown you this before, I believe. This is a supersaturated solution. So when I take the top of this off, it might start this going into crystallization. So let me be careful here, because I want to just take one crystal and have it do. There it goes. See it? All I had to do was open this. Isn't that awesome? Now I would pass this around too, because you can feel it. Temperature is up, so that this is what we call an exothermic reaction. It is given off warmth. Okay, so this was a supersaturated solution, and all it takes is one little tiny crystal to get it started, and then it becomes a crystal again. That's supersaturated. So that stuff there is called sodium acetate. So how can I tell which type of solution it is just by looking? You can't. But you can add a crystal of the substance. If the crystal dissolves, it's unsaturated. If it falls to the bottom, it's saturated. And if it causes the whole thing to crystallize, it is supersaturated. Okay? Probably on Wednesday we will learn, maybe tomorrow, learn about solubility curves. Okay? Your grades are in. A couple of people did very well. About half of us did quite well. The other half didn't do much of anything. So your grade is reflected. You have 2 weeks. You have until May 15th to make up any of that work, and it will still count in last marking period. If you don't, that's the grade that you end up with. See you tomorrow.